We'll now proceed to the Prague testbeds. We'll first have a short introduction by Pavel Burget about the ground floor equipment and challenges, and then this will be followed by a session of 3 talks going into more detail of the actual research being executed there. So Pavel, please introduce us.
Thank you, Tilman. So I will go shortly through what we have in testbed and what areas of activities and research we do. You can see the layout with several stations, and the description of the individual stations is here. I think I can skip it because there were guided tours, so you were able to see it yourselves. I will emphasize here just the 3D printing center that is attached to testbed, where we have various industrial 3D printing machines and technologies, and we are able to print from plastic and metal, which allows us to design various grippers and fixtures and other types of parts that are used directly in testbed. You can also see them downstairs. And then the Smart Grid Lab, which is just to be built, but we already plan projects to be able to focus on the optimization of distribution of energy sources with respect to the processes that are to the manufacturing processes that are controlled and that are supplied by the energy, so that this allows this will allow advanced solutions in the field of energy consumption, energy optimization, and so on. These are some pictures of the machines, and as I already mentioned, we focus on the flexibility of the processes, so that the machines are organized in such a way that we can build various connections and paths and production sequences that can be easily changed and adapted to the requirements of the process and of the parts that are produced. One specific topic is the adaptation to the environment, as is shown here. So it means that we need the robots to be able to adapt easily to the parts that need to be manipulated, and to be able to use a robot or a robotic cell flexibly in production environment. This process of designing the grippers must be very fast, contrary to the current intervals or time needed, which is in the range of weeks, or in some cases even months. We need to shorten it down. So this is one area that we focus on. It relates also to the automatic generation of robotic operation, production sequences, and so on, so that you don't need a programmer to adapt the robot to the specific environment, but you need just an operator that specifies the task, and then the rest is generated automatically. What is really important is the system integration, so that we focus on using standard interfaces which are well defined, and it relates also to having suitable data models. Centralized and decentralized control is considered. whereas centralized is the typical approach in industry today. The decentralized control allows increasing the modularity again, and the modularity also means flexibility. So all this leads to distributed production, where the individual robotic cells and the machines can be understood as stations that are connected with logistic paths, and considering the logistic paths can directly into the production planning allows us to adapt over the whole chain, over the whole value chain of the production. So that not only planning or scheduling of the production at the level of the production cell, but also considering the needs, how to supply the parts, how to deliver the products, how to include a customer into the chain, and so on. If we also consider the smart grid into this approach, then we can include the energy issue or the energy constraint into the whole chain, and can focus on distributing the production also with respect to the suitability of or availability of the energy at respective sites. A special topic relates to the 5G network and edge computing. We are the first site in Central and Eastern Europe where 5G SA private campus was installed, provided by T-Mobile, and it allows designing experimental scenarios for industrial use cases, so that we will be able to demonstrate the suitability of the 5G technology to be used in industry. Here you can see some examples where 5G really helps. So one of them is utilization of augmented and virtual reality in industrial application, edge computing with the fast feedback loop, so that we can use the high performance of the edge computer or server which is connected through 5G to utilize the results of the computation at the shop floor, and then other use cases for mobility and localization, low latency communication to be used in feedback control, and so on. These are partners that we cooperate with in research mainly. So I mentioned T-Mobile as the provider of the 5G technology here, but the cooperation is also going to lead to having the research topic to be able to provide them to industry. So that's all from my side. Thank you for your attention.